This experiment is going to cover sample experiment SE1 LTE SISO using SRS-RAN. For this video, we're going to focus on just the radio and traffic portions and save the vehicle portion for a second part. Here we have two terminals which represent a fixed node and a portable node. The first step we're going to do is we're going to navigate to the folder containing all of the radio scripts. Then, on the fixed node, we're going to copy the SRS-RAN SISO script for the EPC and eNode B into the start radio script. Then we're going to copy the SISO UE script into start radio on the portable node. Next, let's take a look at the configuration parameters that we can modify for this experiment. To do this, we're going to go into the helpers folder. Then we're going to open the start EPC script first. Here we see that there's not really anything for us to configure, so we won't really worry about this file. Next, let's take a look at the ENB configuration options. Here we have a total of 5 options available. First, we have the TX and RX gain that are set for 70 and 40 respectively. These are not necessary for the emulation mode. Next, we have the downlink and uplink frequencies, which we have at 3.41 and 3.32 gigahertz respectively. Finally, we have the number of resource blocks set for 25. We're going to keep these all default for right now. Next, let's take a look at the UE configuration options. Over here, we see a similar set of options with the TX and RX gain and the uplink and downlink frequencies. Additionally, we have an MZ configuration option. By default, this is set for a default value with the final number being the node number, in this case, node 3. Now let's navigate back to the root directory and modify the start experiment script to utilize this start radio file. To do this, we can simply uncomment the start radio script inside of this file. Additionally, we're going to also uncomment the traffic script due to the fact that in order for SRS to continue running throughout the experiment, there must be some form of traffic that is occurring over the radio link. Similarly, over here, we will do the same. Now let's grab the traffic scripts and plug those into the start traffic script that we had just enabled. We have options of using ping or AERPAW for the traffic in this experiment. We're going to use AERPAW for this experiment so that we can see some of the throughput that occurs. On the fixed node, we'll make this the AERPAW server, and we will make the portable node the AERPAW client, which will allow us to send traffic in the uplink direction. Now we're ready to start the experiment. This can be done by running the start experiment script in the root directory. Let's use screen in order to take a look at what is going on inside of the eNode B. Next, I'll start the experiment on the portable node and use screen again in order to see what's happening with the UE. Here we see a lot of disconnects at the beginning, but we can see that the connection is more stable now. If I move the window over slightly, we can see the bit rate that is occurring in the uplink direction is sitting around 4 to 6 megabytes at the moment. Here we can also see that there are occasional disconnects due to the path loss that is included into the emulation. When you are finished with the experiment, we can use Control-A-D in order to close screen without terminating the process. We will run stop experiment in both nodes in order to stop all of the scripts that are running. From here, we can go into the results folder and take a look at the results that we just generated. In the radio log, we see the same output that we saw in screen, now saved to the file. Again, we see the uplink bitrate of about 5 megabytes per second that we had generated through AERPAW. Let's take a look at the AERPAW script to confirm that these numbers seem accurate. If we look in here, we see similar numbers in that there's some 5 megabit throughput at some points. It drops down to lower values occasionally and sometimes a little bit higher, confirming that the data in the radio log seems accurate. We can see similar information if we take a look at the logs on the fixed node. At the E node B, even though it's a little bit more difficult to see, we see similar numbers around 4 to 5 megabits per second occurring in the uplink direction. We can again confirm this by looking at the AERPAW log and seeing similar values as we have seen in the previous log files.